Hi everybody, today we're going to be doing Module 1, Chapter 1, Written Exam. I'm just going to go over some math problems that we've learned. So in question 1, we are to place the digits 8, 10, 11, 12, and 13 in the circles to make the sums across and vertically equal 31. It also wants us to have all the possible answers shown. So I just went ahead and found that 8, 11, and 12 equal 31. So I went ahead and put those horizontally in these three circles right here. That leaves 10 and 13. So I just went ahead and filled out 10 and 13. But you find that 10, 11, and 13 equal 34 and not 31. So by switching the 11 and the 8, you can find that 8 plus 10 plus 13 do indeed equal 31. By continuing with the guess and check method, you find that there are no other combinations that equal 31. So we're able to move on. It then asked us to study the diagram to the right and note that 2 plus 8 equals 10, 5 plus 3 equals 8, 2 plus 5 equals 7, and 8 plus 3 equals 11. It asked us to solve problems 1 through 4 the same way. So we're going to use the guess and check method as well as using variables to solve the problem. What I mean by that is if you start in the upper left circle right here, you can deduce that 7 plus n would equal 12. So you're solving for that empty circle. So you're just going to solve for n right here. You're going to isolate your variable like you always would to find that n equals 5. And then you would put 5 in your lower left-hand corner. Now you're going to find the lower right-hand corner again by solving for n. 5 plus n equals 17. Solve for n, you'd find n equals 12. If you keep going through that problem, you'll find that the circles should be filled in with 7, 8, 5, and 12. And here's my check right here. 7 plus 8 is 15. 7 plus 5 is 12. 5 plus 12 is 17. And 8 plus 12 is 20. So all of those check out in our pattern. So we can move on to this next one, which is solved the exact same way. We just use a variable n and solve for it to figure out all the missing circles. 6 is already filled in, so then you'll just solve for n with the second circle. 6 plus n would equal 21. Solving for n, you find it's 15. You just keep going, and then at the very bottom, you'll see that we filled out all of our circles, and we would place 7 in that upper left circle, and then here's our check, which is 7 plus 4 equals 11, 7 plus 6 equals 13, 6 plus 15 equals 21, and 4 plus 15 equals 19. And now if we move down to this one's where it got tricky. So you'll just solve it the regular way using a variable expression and isolating your variable. And you'll come down here to find my check. I've written incorrect here because 2 plus 3 does indeed equal 5. But 2 plus 3 here is supposed to equal 6. So since 2 plus 3 equals 5 and it's not 6, you should go back and work the problem a different way to see if there's either an error with your math or if there's no solution, which it could possibly be. So we go back, and instead of doing 3 plus n equals 8, we're going to go to the left, and we're going to go 3 plus n equals 6. So by working backwards, we're already solving that 6 to make sure that we didn't make a mistake there. And at the very end, we find that 9 plus 3 is 12, 9 plus 6 is 15, 6 plus 3 is 9, and 3 plus 3 is 6. Now, the only problem with this is 6 plus 3 is 9. It says 8 here. So it's not us that made an error. There's just no solution to this problem. So for number 4, same thing. We're going to start with an equation. 8 plus n equals 18. We're going to solve for n, which equals 10, and just continue to fill out the circles until we're able to come down to our check, which says 1 plus 6 equals 7, 1 plus 8 equals 9, 8 plus 10 equals 18, and 6 plus 10 equals 16. Problem's complete. Now these problem sets, again, were best solved by using the guess and check method and using variables. The second question says 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along the entire edge, and the squares all have sides and a length of 1. So we're supposed to sketch all the figures and find the perimeter around each figure that can be formed. Now you'll find I have found 5 figures here with perimeters ranging from 12 to 20. Now, while sketching, I found that some perimeters are the same. An example would be down here. No matter where you move this square on the top, which that's kind of like a mirror reflection, the perimeter is going to be 14 no matter what. No matter if that's sitting in the middle, sitting on top, it doesn't change that. So I wanted to know which figure had the least and which figure had the greatest perimeter. So we're just going to scroll back up and look at that. So obviously the least is 12 and the greatest is 20. So by looking at our previous work, we got that answer. To solve answer number 2, we must use figures as a guide and a bit of guess and check. but using figures, I was able to find the perimeters easily and find which was least and greatest. For number 3, we're supposed to show all possible solutions for the 2 following puzzles. For A, if one must always move upward or to the right, on the grid shown below, draw a diagram for each possible path from A to B. So I started at the upper left with the original diagram, and there's A, and there's B. Each of these highlighted paths show each path you can take from A to B. Now, some of these look like mirror reflections, like this one and this one. It's just a flip or a rotation, however you want to phrase that. So there are only 12 paths from A to B. For 3B, much the same. You're supposed to take the diagram and find the paths possible from C to E. How many paths are possible? Now you have to follow the arrow patterns because you can't go past an arrow that's pointing the opposite direction. So at the very end of that, you'll find that there are 4 paths, which I've highlighted right here. Okay, number 4. These are addition pyramids in which each number is the sum of the 2 numbers immediately below. For each of the incomplete addition pyramids, show that the values in each square can be determined by forming and solving an equation for an unknown variable. So not only are you trying to solve the empty spaces, but you're also trying to solve for the variable as well. So you'll see in A, we have the variable x. So instead of solving for x first, I want to go ahead and solve for those blank spaces. How I do that is, you know that 7 plus 3 is going to equal 10. You're going to then take 25 and 10 to find that missing blank. So you'll take 25 subtracted from 10 is 15. Now you're going to solve for your x because x plus 7 is going to give you 15. So you're going to solve for x and find that x equals 8. You're going to find, here's your check. So 8 plus 7 equals 15. 7 plus 3 is 10. 15 plus 10 is 25. Coming down, you're going to find a bit of a different problem. You see this one has parentheses, which sometimes scares people. It used to scare me because it looks a little bit longer and more tricky, but it's not. Because you know 1 plus y is going to equal that blank square. Y plus 2 is going to equal that blank square. And then those 2 blank squares are going to equal 15. So you can conclude that 1 plus y plus 2 is going to equal 15. You come down, drop your parentheses, combine like terms, and you wind up with, we'll just skip down to this part, 2y equals 12. You're going to isolate your variable by dividing by 2, which means y equals 6. So now you can better go back and finish the whole pyramid because you know y equals 6. So 1 plus 6 is 7, 6 plus 2 is 8, and 7 plus 8 is 15. Here's your check work, and you know that your pyramid is correct. Now for this pyramid, you're going to see it's a bit trickier because these 2 blanks are empty. So what you're going to do is, I like to go ahead and put my variable spots here because you're going to know that 7 minus 2 is going to give you this middle spot right here. So I just went and wrote z minus 2. I said 7, but that's up here. Then you're going to know that z plus 7 equals right here because 9 minus 2 is 7. Here's your end equation. So you're just going to come down here, and your goal is to isolate the variable z, which comes to be 10. Then you can plug in 10 where there were z's. So you're going to have 10 minus 2 is 8. So 2 plus 8 is 10. 8 plus 9 is 17. And 17 plus 10 is 27. And that is also your check work as well. These are my favorite kind of problems, word problems. Sometimes they're tricky. These are my favorite, just trying to find matches or possible combinations. So we have 4 married couples belonging to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names in some order are David, Will, Gus, Floyd, and we're supposed to use a table to find who's married to whom. Now, we will take this information and deduce it until we arrive at the answer. This uses deductive reasoning because you start with specifics and then you wind up with a possible outcome, which is going to be true because you've taken something true and you've just deduced it to a, its simplest form. So Floyd is Josie's brother. Josie and Gus dated, but then Gus met his present wife, and Kitty is married to Will, and Ann has 2 brothers. Ann's husband is an only child. You come down here, and we're just going to use, I put no and yes. So X is no, check is yes. And you're just going to go through here. You're obviously going to know that Floyd cannot be married to Josie because that is her brother. Josie cannot be married to Gus because they dated, but then Gus met his present wife. You're going to know that Kitty is already married to Will, which means Josie is left with David. Kitty's married to Will. That leaves Floyd and Sarah and Gus and Ann. You'll see that Ann has 2 brothers, but Ann's husband is an only child, so that kind of crosses each other out to figure out David and Josie, Will and Kitty, Floyd and Sarah, and Gus and Ann are the married couples. For question 6, we'll be looking at trapezoidal numbers as well as using inductive reasoning by taking the trapezoidal numbers and using dot representation, in which you get a better understanding of the problem. You consider trapezoidal numbers 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 1, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1, and then the nth trapezoidal number, where n is a positive integer. You're supposed to create a dot pattern representation of the trapezoidal numbers. 1 plus 1 plus 1, there's 3 dots, very simple. 1 plus 2 plus 2 plus 2 plus 1, and then 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. So all those are represented by kind of like a triangle type shape. Now, I want you to notice that 1 plus 1 plus 1 is 1 times 3, 1 plus 2 plus 2 plus 2 plus 1 is 2 times 4, and so on. So now I want you to take the trapezoidal number and rearrange it into a rectangle that has 2 more columns than rows. So this one's already like that. It already has 2 more columns than rows. Rows are horizontal, columns are vertical. So here we had 8 dots above, so now we have 8 dots below. We've just arranged them to where it's a rectangle and to where we have 2 more columns than rows. Same here, 15 dots just rearranged into a rectangle in which we have 2 more columns than rows. Now it wants us to use inductive reasoning to show what general formula gives the nth trapezoidal number. Based on the previous information, you can conclude that the nth trapezoidal formula is n times n plus 2. A little check work on that is if you were to take this first set had 3 dots. So if you take 1 and plug it into the n spot, you have 1 times 1 plus 2, which would be 1 times 3 equals 3 dots. And you can just go through that with each number. And the second one had 8 dots, and this shows the work, which equals 8. And the third one had 15 dots, which this shows that equal 15. So that concludes our Module 1, Chapter 1, and I hope you liked watching.